Fluid mechanics is cool because it occurs everywhere around you. You can see it, you can visualize it, and you can enjoy and appreciate it. I'm Howard Stone. I'm a professor in fluid mechanics, and I study problems in engineering, physics, and some chemistry. Yeah, this is an example where a liquid is placed on a solid and it spreads out. We refer to those situations as wetting. So what's going on when you wet your hair? You need to understand how the water wets your hair fibers and how it can draw them all together. It's easy when you understand the different pieces, but in many of these problems there are several pieces. Another area of fluid mechanics and physics and engineering that's very exciting is to make devices that are the size of the human hair and manipulate fluids in them. This is a field that's called microfluidics. And in my group, we've tried to use these devices to create the kinds of materials that have bubbles of gas and droplets of liquid in them, and also to shape the liquid. In fact, to shape the liquid in the form of very long fibers, which you can polymerize and make into materials that essentially look like hair. And one area where fluid mechanics meets biology involves bacteria. Bacteria are inside all of us, and bacteria form biofilms. And there are many fascinating phenomena that happen when fluid flows meet bacteria, as we've discovered in some of the experiments we've done with these small devices and bacteria. What we discovered is that although we expected to find the biofilm on the surface of the device, and indeed it is on the surface, we also found, if we looked exactly in the center of the device, that the biofilm was forming as a string-like structure in the middle of the device. It could have significant applications, since after all, if you don't know where something is, how can you keep it from forming, or how can you prevent it, or how can you even remove it? What you're seeing here is very beautiful. It's an emulsion placed on the surface of water, and a very dramatic flow occurs. You could do this at home with all the materials you need to, for example, make salad dressing. So look at this. This is a dancing disc. It's an experiment where you take a thin sheet of material, which is a lot like a sponge, and when you place a liquid on it, the liquid's absorbed by the material. The material then tries to stretch and bend, and the consequence is it's quite lively. Most of what we've seen we can explain. We have to understand first how the fluid goes into the material, how it swells the material, and how an elastic material can bend when it's only swelling on one side. And we can do this using principles from physics and engineering. A lipid bilayer is what surrounds every cell, and so we use the same molecules that make up the cell to make these model membranes, so-called bilayers. We discovered that when the bilayer membrane is compressed, the molecules that make up the membrane are expelled, and they're expelled into tubules, cylindrical tubes of molecules that form these long worm-like shapes you see in the video. I like to have an environment where people want to be there, where people enjoy not only the work but each other, where they learn to collaborate and where they learn to ask their own questions, where they learn to create answers and where they learn new techniques. And trying to do that in an environment where everyone can grow and collaborate and become better people and better human beings is one of the great things about being at a university. I want to make an environment where people are happy and excited to be working. Yeah, sometimes you just have to start over and you need space for new ideas. And so we start again. You see this and it's just beautiful. It shows you why science and engineering are full of continual surprises.